Assalamu alaikum students. Today our topic is geometrical optics and subtopic is total internal reflection. SLOs of these topics are define total internal reflection, state conditions necessary for total internal reflection, describe the use of total internal reflection in light propagation. You see these three diagrams, these are the semicircular glass blocks. In this diagram, you see the light rays enter from denser medium to rare medium. In the previous class, we have done the refraction of light. Refraction of light occurs when bending of light takes place. Here also, total internal reflection belongs to refraction of light. When light enters from denser medium to rare medium, that means from glass slab to air, it bends away from the normal. In the previous class, we did this phenomena. In first diagram, light enters from denser to rare medium and bends away from the normal. The angle of incidence you see is smaller than the angle of incidence. If we take another ray of the same glass slab in which the angle of incidence is greater than the previous angle of incidence, this angle is greater than this angle, then light refract on the surface of the medium and makes an angle of 90 degree. If the angle of incidence is greater, then angle of refraction also will be greater. In this diagram, this angle is called critical angle, right? What is critical angle? At which angle of refraction becomes 90 degree. This angle is 90 degree. So this angle of incidence is called critical angle. Again, in the third diagram, same semicircular glass slab. When angle of incidence increases more of critical angle, then no refraction take place. Instead of refraction, reflection occurs. Light bounce back into the same medium and obeys laws of the reflection, in which angle of incidence is equals to angle of refraction. So what is total internal reflection? If angle of incidence is greater than critical angle, then light comes back into the same medium, and then this phenomena is called total internal reflection. Okay. Next, the process of total internal reflection. What is it? When ray of light traveling in denser medium enters into a rare medium, it bends away from the normal, just like the previous diagram. This diagram, when ray of light enters from the denser medium to a rare medium, the ray of light bends away from the normal. If the angle of incidence I increases, the angle of refraction R also increases, as you see in the diagram. For a particular value of the angle of incidence, the angle of refraction becomes 90 degree. In the second diagram you saw, when the angle of incidence becomes larger than the critical angle, what is critical angle? The angle of incidence for which angle of refraction becomes 90 degree is called critical angle. So no refraction occurs. The light rays come back into the same medium and reflection take place. The entire light is refracted back into the denser medium. This is known as total internal reflection. The whole phenomena is known as total internal reflection. Look at the diagram. This is water, denser medium, and here you see it is air, less dense. N1 is denser or N2 is less denser or rare medium. When light enters from denser medium, this is the source of light. For example, bulb, torch. Okay. When light rays enter from denser medium to rare medium, denser medium to rare medium, perpendicularly. So there is no reflection. It will go as it is without any bending. If light rays goes in this way, that angle, it makes an angle, then refraction takes place and angle of refraction is more than the angle of incidence. Take another ray. In this ray, if angle of incidence is greater than the previous angle, suppose this angle is of 35 and this angle is of 45 or 50 greater than, then angle R also increases. In the previous case, if the angle R is suppose 45, now it is of 90 degree. So it is, if angle I is increases, angle R is also increases. The angle R at which if the angle R becomes 90 degree, then angle I is called critical angle. If the angle R becomes 90 degree, then angle I is called critical angle. Take another angle, another ray. Here also you see that angle I is greater than angle previous critical angle. So no refraction takes place, the light comes back into the same medium and reflection takes place. So in this diagram, for this ray, if the angle I is greater than critical angle, total internal reflection takes place. There are certain conditions necessary for total internal reflection. Two conditions. Number one, the light must travel from denser medium to rare medium. Light must travel from denser medium to rare medium. So total internal reflection takes place. Second condition is the angle of incidence must be greater than the critical angle. Otherwise, total internal reflection does not take place. These two conditions are necessary for total internal reflection. What are the uses of total internal reflection? Total internal reflection basically used in optical fiber or fiber optics, which has number of advantages in telecommunication, medicines such as endoscopy, gastroscopy, sensors, military applications, and industries. First use of total internal reflection is in optical fiber. Optical fiber is also used in these 5 areas. This is the diagram of optical fiber. You see, optical fiber is light pipe, flexible. It is flexible, easy to carry, soft. It can bend easily, and when light enters from this side, it reflect back in the inside the optical fiber like this and obey total internal reflection over here. The path of ray of light, you see, it is reflected internally and comes out from this side. This optical fiber consists of two layers. Outer layer is called cladding. It has low refractive index, and inner core is called inner. This inner side is called core, and it has high refractive index. Another picture of optical fiber. Right, when light enters in this way, it bends towards the normal and hits the inner side, and total internally reflected and reflect in this side and comes out this side. The refractive index of air is 1, and the refractive index of the core is 1.48, and the refractive index of cladding is 1.44. This optical fiber is used in medicine in endoscopy. You see, this is the diagram of the endoscopy. This is an endoscope. In this, an optical fiber is used. Another picture of optical fiber which is used in telecommunication. Communication purpose, these are the bundle of optical fibers. All these are the optical fibers. Total internal reflection is also used in right angled prism. Total internal reflecting prism, which is used in many optical instruments such as cameras, binoculars, periscope, and telescope. This is the diagram of a periscope. You see, these two prisms, total internal reflecting prism, is used in this periscope. The path of ray of light is this way. If the light enters in the periscope, it hits this side of the prism and reflect back in this direction and comes out in this way, and you see the picture. Binocular. In binocular, the prisms are used in this way. Total internal reflecting prism is used in this way. Reference video. I am sending you the link of the reference videos. Must watch these videos. It would be help for your clarification. Thank you, guys.